Love water. Great. So let's just get right into it then. So welcome to the mock interview. We're starting 4 minutes late, unfortunately. Sorry about that. But we're going to be doing about 45 minutes of problem solving. Okay. And then we'll do some feedback and questions on whatever you have for me after. How's that sound?
Yep, that sounds good to me.
Great. Okay. So the first problem is a Leetcode problem. Okay. I want you to write me a function called find center. Okay. So find center is a function, and you're going to take in a list of edges. Okay, and the list of edges, it's represented as a list of int. Okay, it's a list of int. That's how an edge is represented. The list of int. Each int, it's a pair essentially. Think of it that way. It indicates a edge between two nodes. Right, it indicates a pair between each pair. So in the int, it represents a edge between the two nodes there. Okay, so you got that down. Okay, and then you're gonna return a integer. Okay, and this integer it represents a node that is the center of the graph. Okay, and I'll explain what center means in this case. So, the definition of a center node is it is a node that has exactly n minus one edges that connect to it. In other words, the center node connects to every other node in the graph.
Yep. So just for clarification, so the center node would be connect to every other node in the graph, right?
Yes.
Okay. Sure. All right. And that would be all right.
Yeah, that's all.
Okay. So we need to write a function to find a center that's take in a list of edge. Okay. So it's integers is a pair between two nodes, returning integers that represent a node that's the center of the graph. So we need to return a center. Um, okay, list of edge. So let me enter the drawing here. So let's say we have okay, maybe we have a node. So the first questions that I have, so we have a list of edge. So our graph, would it be like um directed graph or undirected graph? Let's say if we have a node, um, um, right? Let's say we have this is node A, B, C, and D. So in this case, can we assume that the graph will be undirected graph or directed graph, like
This will be an undirected
binary?
graph.
Okay, okay, got it. And the center node has connect to every other node. So let's say if we have here we would have the center node. Maybe just call it E. So the center node is will be connect to every other node in the graph. So it will connect to node D, and it also connect to node A, and it's also connect to node B, and it's also connect to node C. We need to return an integers that represent a node. That is
Yeah.
the
So in this case, you
center.
would return E.
Oh, okay. So in this case, we need to return E.
Yeah, and E would be represented as a number, right? So your edges are represented as a
Oh,
pair of integers, not a pair of characters. But you would return E. Yeah.
oh, okay, got it. Okay, okay. So let's say maybe we would have um pair of integers, and maybe this one will be and this would be maybe this would be 2, 3. So for the pair of the integers, can it be a negative values, or is only contain positive values?
Okay. So I want to just clarify something here. So I think it's a bit of confusion. Just to be clear, every node is a number, and a pair of numbers is an edge.
Oh, I see, see. Okay, got it. Oh, I see. So let me just maybe erase it. Um, so okay, so let's just be maybe, yeah, which is just in this case, maybe we would have label this would be 1, 2, 3, and 4 for A, B, C, D, and E would be 5. In this case, 1, 2, 3, 4, and 5. Okay. Um, so let's say maybe another example. What if we have um this so in this case we will return 2, right? That would be the centers
Yeah.
of the graph. Is that correct? Okay. Okay. Okay, makes sense. Thanks. Um, so this would be, so one approach I can thinking of is that maybe we can use um to traverse. um, let's say we need to start from this node to go to this node. Yeah. So maybe we can go to center node. So I think we can do the best traversals to start to find the graph that have a cycle, right? If we look at the first example,
Okay.
um, if we have like 1, 2, and 5, so this this graph would create a cycle. And then if we look at like 2, 3, and 5, this is also a cycle.
Okay.
And if we look at 3, 4, and 5, this also create a cycle. And then the last one is would be 4, 1, and 5. That's also create a cycle. So um, yeah, we can do like DFS or maybe a unified algorithm to find the connected component. In this case, um,
Right. So, but all the nodes are connected,
all the nodes are
right?
connected.
There, if the nodes aren't connected, there can't be a center. Remember, the definition of the center that I gave is that a center node is connected to every other node in the graph.
Center node connect to every other node in the graph. Hmm, that should be undirected. Yep, that's true. Okay, maybe if we start with the DFS traversal, if we start from this node and then visit the neighbors, I think in this case, if we can do like DFS or BFS is also fine. Do you think that I can start with the DFS traversal or BFS traversal would be
Yeah. So maybe before we
um
do any
would
traversal, I want to ask, why are you traversing? What's the goal of the traversal?
um so if we find graph that have a cycle, right? Um
Okay.
in this case, if we do like if we start from A, then A go to B, um and then B can also the centers. If we look at another example, if a node like this, a graph like this, so in this case, if we have, 1, 2, 3, right? So in this case, um, one, uh, one also connect to node 2, and then one also connect to node 3. So let's connect to every other node. If we break the cycle, um, so let's say 1, 2, and 3. In this case, we would have to return node 3, right? So node 3 will be connect to node 1 and node 2. So
Yeah.
node 3 will be the centers of the graph.
Yeah.
Yeah. Um, so if we start the DFS, the depth first search to find the path between um the, of the node in the graph. So there would be a path from um node 3 to node 1, and there's also a path from node 3 to node 2.
Yeah. That 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 would tell you that, but what would you do with it though?
So if node 3 connect to node 1, and then node 3 connect to node 2, then node 3 is the centers, and then we check um node 1 connect to node 3, but node 1 does not connect to node 2. So that's why node 1 here cannot be the center node. Also, we would need to check for node 2, right? If we check node 2 connect with node 3, but node 2 do not connect with node 1, so node 2 also cannot be the centers.
Yeah, that's true.
So um
So what's a property
how do
of a node that is a center?
so property of a node that is centers
Yeah, what are
that
some
is
properties you
connect
noticed?
to,
Yeah.
so it will connect to every node
Yep.
in the graphs.
Yep. That's true. That's the only node that connects to all the other nodes in the graph. There's one center.
Yep.
Okay. And what does that mean about the number of edges it has?
Does it mean about a number of edges that have? Oh, let's say we have 3 nodes, and then the number of the edge is 2 edges.
Yep.
Um, oh, okay, I see. So in this case, so we have 3 nodes and then maybe n minus 1 edge. So 3 nodes, then n would be n minus 1 edge. N would be the number of nodes that we have.
Okay.
Okay.
And can any other node have this property?
Any other node have these properties? No, I think only the center node have the property that's connect to every other node, and every other node, like in this case, if we look at node 1 and node 2, they do not connect to each others. So let's say if we have a graph uh, like this, also, yeah, and then we have 1, 2, 3, 4, and 5. So since node 5 is connect to every other node, connect to node 1, 2, 3, and 4. So node 5 will be the centers, and every other node, like one doesn't have a connection to node 2 and then 1 also doesn't have the connection to node 4. Um, so yeah.
Yep, I agree. So the center node is the only node which has a property of having n minus 1 edges.
Yep. Um, n minus 1 edges. Okay. Okay, so if we have 3 nodes and then n minus 1 edges, okay, if we have like a number of nodes, so if we have like this one, we will have 5 nodes and then 4 edges. If we
Yeah,
do,
yeah,
yeah, you can go first.
yeah. So the center node is the only node which has n minus 1 edges, right? We've established that. Now
Yep.
we're trying to find the center node.
We
So
have
there's a
to
couple things you
find the
can do
center.
to find the center node. One thing you could have done is do a form of traversal, but to do the traversal, you had to construct the graph. So you would need to construct a graph from the edges, and then you can do a traversal. The other way is leveraging the fact that we know this is the only node that has exactly n minus 1 edges. And then by doing some analysis on the edges themselves.
I see, I see. Okay, so yep, I think first we can, since it's a undirected graph, we can construct the graph with the adjacency list, construct the graph, and then we can start the depth first traversal to all of the neighbor nodes, like other nodes in the graph. Um, and then maybe we can have to keep track of the node that we already visit. We can have a visit set to make sure that we don't visit the node again. Um,
Okay, we can do that.
yep. Yeah, that would be my initial thought. Say,
Okay, that's yeah. That's you mean that there's that's definitely one way to do it. If that's what you're comfortable with, we can go with that.
so can I start with the coding now?
Yep.
Is it sounds good to you? Yeah. Okay. Maybe we can have a functions called file center node. We would need to check in a list of edge. So yeah, we just take in a list of edge. So that would be the list of the integers. Okay, so first we will need to construct the graph view adjacency list. We will need to build an adjacency list. So so I think we would need to have take in the number of nodes also.
You won't be given the number of nodes. Your only input is a list of edges.
Oh,
But you could calculate the number of nodes if you need.
okay, gotcha. So, um, you only, okay, so maybe this would be, range and then for a in edges, we would need to construct adjacency list. That will be a append B, and then append 8. Yep. And then we would have a visual set to keep track of the node that we already visit.
Okay.
Um, and then we would have another functions that can be the DFS or the helper functions um, to travel from the node. So mm, this would take in the node and pairs the node. So for the base case, we need to check if the current nodes that already in the visa set or not. So um, so if the current node not in the visa set, we will need to add the node into the visa set. Then we can start the traversal from the current node to its neighbor node. So the center from if we start from 2.
So why are we doing DFS? Like, what is the goal of the like death first search? What are we searching for?
We searching for all of the path in the graph, right? If we start from one node, then we will go all the way down to the, if not, like we can go as far as possible in the graphs that we have. Um,
Yeah, but what are we searching for?
we we're searching for the centers in this case, and
Okay.
we're searching for if the node that is connect to every other node
Yeah.
in the graphs.
Okay.
So if that not, yeah.
Yeah, so that's the base case, right?
Oh, if the node connect to every other node in the graph. Okay, that's the base case. So if not in visit, we add the current node to the visit set. So what if the current node is already in the visit set? In this case, um, if the current node is already in the visit set,
So let's not care about it being the visited set. Let's talk about what happens after. Okay. Can you implement check center?
yep, if check center return node. Oh, okay. Check center we just return node. Okay, gotcha. So the check center function would return uh a Boolean values, right? That would return true if not in the centers in the graph, right? That's correct, right?
So check center will return true if and only if the node that's passed in is the center node.
Okay. If not a passing is centers node. If not, check centers. Okay. Maybe we would have that, and then we have,
Yeah,
so
so let's
if
think
the
about what's
name,
going on here, right? So we want to do a traversal across the graph. That makes sense. I want to do the traversal until a node is the center,
we would
right?
traverse
We
until
want
node
if we
is
don't find the
centers.
center, it must be the last node that we encounter, right? So we want to traverse until we find the center. Does that make sense?
Okay.
Okay.
We want to find until the centers. That's
Okay. So now that we know that, let's sketch this out. Okay. We assume that check center. So okay. All right. I'll draw some notes. Right. So where's the notes? Okay. So what are we doing here? So if this check passes, that means we found the center. Right. So
mhm.
later on, right, what you're thinking is, right, you do a helper root, or you call it. Oh, well, I don't know what you're present. You put in root, right? And then you can do return. Right. So this is center equals this return center. This is what your goal is, right? This is your goal.
Mhm.
I don't know what your pairs is. You can do that later, right? But this is your goal. Okay. Now the rest of the helper method is a regular DFS, right? It's regular
Oh, okay.
DFS. You have a base case, which is you run into a cycle. Okay, sure. Another base case is you're done. You're done because you found it, right? If you're over here, that means you
Oh,
haven't found it yet, which means that you need to implement the rest of the logic, right? So if you're here, you were gonna do, if neighbor not in visited, you would do what? Uh, you would do helper what? Helper neighbor, right? Like continue from here. So continue with the regular DFS.
oh, okay, okay, gotcha. Oh, okay. So if the neighbor not in visit, okay. Mm. So we need to check, implement the check center functions. So if uh, so if not two connects to two, not three, okay. So we will need to oops, return um it's not that connect to we at the curve node. Okay, the next node will also connect to first node, connects to this node.
Let's hit pause on check center. Let's hit pause on check
Mm.
center. Let's assume that check center works correctly. How's that sound? Okay. How about you finish the rest of the DFS implementation?
Okay, okay, gotcha. So if okay, check center return the node if for each neighbor and then the neighbor is not in visit. Uh, and we have to add um a neighbor to the visit and then we can start with the DFS functions or the neighbor. You can visit, we add the neighbor node into the visit set and then we call the DFS functions from that neighbor nodes. we add the neighbor and then we check. So for the ASK, so in the case that the neighbor node is already in the visit set, um, in this case, we already visit the node before, so we just um, continue then.
Okay. Let's talk about time and space.
Time space complexity. So for the time complexity, I think we would have to visit every node in the graphs. So that would be v plus e. V is number of nodes and is number of edges. For the space complexity, it will also v plus e. Did we do the DFS traversal? Yep.
Okay. Um,
Yep.
can you elaborate a bit on why it's v plus e though? Like, why is DFS v plus e for space complexity?
So if we look at the, okay, let me go to, so let's say in this example that, okay, where can I look? Okay, so let's say if we start with this example from from node 5 to node 2 and then node 5 to node 1, we need to um, do the DFS traversal from 5 to 2 and 5 to 1 and 5 to 4, also 5 to 3. So that's we need to check all of, we need to visit all of the node in the graph once. Um,
Okay.
then yeah, we would have to traverse, the edge would be the path from the node 5 to every other node. So we also traverse like looking from this this node, the center node, to every other node. So we also visit the edge of the edge in the graph also. So I think, I believe the overall time complexity is be all of v plus v. Yeah.
Okay. Let's talk about it.
Yeah.
Let's talk about it. So, what went well? What went well? What do you think could have been better here?
Um, I think I should ask more clarifying questions at the
Okay.
beginning to um, have a clear understand um, what the problem is trying to, of what we're trying to find. Um,
Okay. Yeah.
yeah.
Yeah. No, that's true. How about what went well?
Um, so I think maybe I should communicate um, more with you about the thought process and also each of the step that I um each of the code that I write. So And what else? I think I could do a little bit better on the implementations for the um, DFS functions. Yeah, that should be like um, the template. So I should maybe code faster um, for the Apple DFS functions.
Yeah.
And yeah, yeah. So do you have any like other feedback for me?
Yeah, we can talk about a couple things here. Um, I mean, the first thing I'll say is like, the problem isn't actually that important. You could go solve it in your own time. That's not what I'll focus on. I'm sure you can figure that out. One thing I will maybe focus a bit more on is that, there were hints that were given that you probably could have used more. So what I mean by
Oh,
that is there's kind of already two hints going on here. The first hint was why why are edges giving to you, right? Like why don't they give you an adjacency list? Why is it they give you edges, right? Why is that not they give you an adjacency matrix even, right? They're giving you edges specifically, right? There's a reason for that, right? That's the first thing. That's a bit more subtle, right? That's fair. You probably missed it, right? The second thing is
yep.
when you were diagramming the solution out, right? Like why am I asking you what is DFS going to do, right? Like you can use DFS, right? In the situation I laid out here, if you implement a check center and if you fix the bug in the helper, I can talk about that later. This would work, right? It would not be optimal, but it would work, right? So, but you have to be clear about that. What are you searching? DFS is depth first search. Searching for what? Okay, obviously this probably search for the center, right? Okay, so it's search for the center. So if you're searching for the center, how do you know if you're the center, right? So when you think about these logical questions, you should be already piecing out. Oh, that's a helper function. Oh, that's a this condition. That's a that condition, right? So these are hints coming out. What are you searching for? And then another hint that was given was about. And this one I spent a bit more time on hinting, which was what is a unique property about the center node? The center node is the only node in the graph that has n minus one edges, right? Why is that important? That's important because you don't actually need to traverse a graph to find the node, right? Why is that? Because
Oh,
the edge is given, n minus one of the edges will have one number, right, of the center node, right? And additionally, this is a hint. I don't think you quite picked up on this one, but this is another one that was meant to be a hint, which is the center node is the only node with n minus one edges. It is also the node with the most edges,
oh, the node with the most edges. Oh, true, true. Yeah, yeah. I see. Yeah.
right? So if you were to make that connection, that this problem would essentially become in a list of pairs of numbers, find the number that appears the most often.
Oh, okay, gotcha. Okay. Yeah.
So a couple understanding things there, right? So a couple things there, hints on what, right? These are things that when the interviewer is telling you about these kind of things, especially when the interviewer is telling you that you have a solution, you have a DFS solution, and there's another option. What they're actually telling you is that your option is bad, and that you should do the other one if you can understand why. Right now, in this case, if you don't
Oh,
understand why, there's nothing you can do, so you have to do DFS. But this is not a DFS
oh,
problem. This is not a search problem. This is a counting problem.
oh. I see, I see. This counting problem. Okay.
Great.
Yeah, yeah. So yeah, I misunderstand about the problem. Yep.
Yeah, and we can talk
So
about the. Sorry, go ahead.
okay. So would oh this is counting. So this would be counting the number of edge in this case, right? Because the sensor node will have the most edge that connect to that node, right?
Yes.
So okay, gotcha, gotcha. I got it. Yep.
Cool. Yeah. So there's some other stuff to talk about here. So again, right. So the problem I won't speak about. The problem doesn't matter. The problem you can go figure out your own. That's not important. Some of the stuff I want to talk about is, for example, let's talk about the time and space complexity, right? Time complexity, V plus E, that is correct for DFS. However, are we doing DFS here? That's a question. Why do I ask that question? Because your input to DFS is node, right? Your input to DFS is node.
Oh,
But how do you calculate node, right? How do you even generate the input to the DFS? So you generate node by generating the adjacency list first. What is the complexity of generating the adjacency list? Do you know?
so for the adjacency list, it's also all of V time, if I remember correctly, it should be all of V time E.
Yeah, so it's going to
Wait,
depend on a lot of things. So one thing it's going to depend on is, first of all, what's the density of the graph? Right. In this case, it's not very dense, but you didn't say that, so you can't assume it, right? Another thing is going to
mhm.
be, how do you find n, right?
How
You
do you
assume you know,
find it?
you assume you know the
Oh,
number of nodes ahead of time, but you don't, right? So like what I'm getting at is not that you're wrong. V plus z is actually correct for this one, but you didn't justify it correctly. You didn't account for all the pre-processing you're doing. So there's a
oh,
lot of
okay,
stuff
got
here that's going on that you missed, right? And then why does that matter? That matters because if you don't know what you missed, you don't know where
Mm,
the rules don't apply. And you
yep.
you were like, I think you actually already made step one into making this a realization, right? Space complexity, V plus E, correct for DFS. Actually, sort of correct for DFS. Do you know the more correct space complexity for DFS? In other words, let me ask you this:
Oh,
what causes DFS to use space?
what causes the DFS to use speed? I think because of its go very depth. Like if we go to the lift node, so the recursion call stack, maybe it would grow a lot more if we call it so many times.
Great.
Is that correct?
That's
Yep.
that's correct. So the space complexity of DFS is the is proportional to the depth of the call stack. That's correct.
Mm-hmm.
Now let me ask you this: what is the depth of the call stack?
What is the depth of the call stack?
Right. Open the drawing tab.
Yep.
Open the drawing tab. Pick any one you want that has a center. What is the maximum depth of the call stack?
Depth of the so okay. So let's start with this one. If we starting from the centers.
Start anywhere you want.
Okay, so let if we start at the node one, it will go to node five, and then this will go back to node one, and then since there are no connections between node one and node four, also node one and node two, and then if we start from node two, there are no connections from node two to node one and node two to node three. Also, only the connection from node 2 to node 5, which is the centers. Um, the depth, so it will recursion call stack. It will call the depth of the recursion call stack. It would be the number of the number of edges, right?
I think you're on the right track. The
Yeah.
the the maximum recursive depth is two. The maximum recursive depth for any graph that has a center is two. Why is it two?
It's-
It's two because you can go from any node to the center, which is you can go from any node to any node in two steps.
Oh, it's two. So it would be a constant, right?
So DFS will be constant, but DFS is not the only work you're doing. You can't forget that. you're also doing
Mm.
an entire adjacency list.
Oh,
So it would still be v plus e minimum.
mm-hmm.
But again, as a
Yeah.
justification, the DFS here is actually constant space because the maximum depth of the call stack is at most 2.
Okay, I see. I see. Okay. The depth of maximum is two. Okay. Why
Okay,
is it two again?
it's 2. It's very
Can
simple.
you clarify?
Yeah, it's 2 because you can go from any node to any node in 2 hops.
Any node? Oh, like the bidirectional, right? You can go from five to two and two to five, right?
You can go from 1 to 3 in two hops. You can go to 1 to 2 in
Ah,
2 hops.
okay.
In other words,
Yeah.
you cannot draw a graph that has a center and requires a depth of 3 to traverse between any 2 nodes.
Okay, I see. I see. Mm,
Does that make sense?
yeah, kind of. Yeah.
You can do that as homework. I'll write down this homework in the thing.
Yeah.
Prove that a graph with a center. So if a graph doesn't have a center, this doesn't apply. Um, has the following. Um, between any 2 nodes that is at most depth 2. And in other words, alright, you can rephrase it. Impossible to draw a graph with a center that has a shortest path with depth 3 between any nodes. So you can do it for homework.
Okay, gotcha. Yep.
Okay. Anything else? Any other questions about this problem or about the interview?
Um, so so do you have any others advice or feedback that I should um start focusing more to improve for the next time, whether this would be like communicate or use more hints like you said before, or um I should add more clarifying questions at the beginning to understand about the problems like more, right?
Yeah, I mean all of that, right? So
Mm.
one thing is that you didn't understand how edges were represented. You were putting a pair of numbers per node. That's not the right understanding, right? So feedback for that,
Oh.
go study graphs again, I guess. Go study graphs, go study how edges are represented. That's the first piece. Second piece, like you said,
Mm.
take hints. If the interviewer is giving you a hint, that means you're already wrong. You're already
Mm-hmm.
wrong. They need you to course correct to bring you back up to speed, right? So when you get a hint, you should absolutely try to understand what they're saying. Okay, if you're on the right track, there's no need for hints. Put it that way.
Mhm.
Uh,
Okay, got you.
Clarifying questions, that kind of stuff that ties in the first point again, like we said earlier. Graph edges are one thing, but also you have to catch when you don't understand something, right? You have to be
Mhm.
real with yourself. If I didn't tell you that's not how edges are written, would you have found out yourself, right? If you would have found it yourself, then that's okay because you would have fixed it. If you wouldn't have
Mhm.
caught it yourself, then that's an understanding problem. Like you didn't even realize that you didn't know what's going on, right? And of course, part of that will get better as you understand graphs better. But this is not really a graph problem. That's a do you understand edges problem, right? Trees have edges too, by the
Mhm.
way, right? Trees have edges. So
Yep.
how's that work, right? So
Yep.
that's a general feedback there. Otherwise, be very clear what your goal of writing this code is, right? You're writing DFS. Okay, DFS means you got to search. So when I see that you're writing
Mhm.
DFS helper, you have a base case, and then you go immediately to iterate through the neighbors. I from that point on understand that you don't know what a DFS is because you
Mhm.
missed the entire point of the exercise, which is like what do you return, right? Like
Yeah.
what do you return? You're not return if you don't have this and just do it this. There's no return value, right?
Yep.
What's the point?
Yep.
So you have to be very clear about why you're doing something, right? You can use DFS. Like if you do it this way, that's okay. You can use DFS, right? But if you do DFS without the node return, then that doesn't do anything, right? It just returns void, right? So you have to understand that. So always be clear
Gotcha.
about what your immediate goal is. My immediate goal writing in DFS is to traverse the entire graph, and then for each node I haven't already checked, I'm going to check if it's a center, right? That's a valid use of a DFS in that case.
Yep. Gotcha.
And then, I mean, obviously, the last one would be, this time the problem is a bit hard, I guess. So we didn't have time to talk about edge cases and tests and bugs. But in your own practice, you should be talking about that, right? So in your own
Hmm.
practice, if you just assume this code works, what is the bug? In this case, I'll help you.
Yeah.
The bug is that if the bug is that you're not tracking the helper.
Yeah. Yep. All right. All right. Thank you so much, Leo, for your feedback for this time. And yeah.
You're very welcome. You're very welcome. Hope you learned.
Yep. Gotcha.